This is the Hardinge Speed Collet Chuck that I picked up at the Bar Z Summer Bash this year. It's seen some use and it's pretty gross, so today we're going to tear it down, clean it up, and get it ready to run.
Welcome back to Cloud 42. I'm James. You may have seen in a previous video that I picked up a Hardinge 5C Speed Chuck at the Bar Z Summer Bash swap meet this summer. Seems to be in okay shape, but we won't really know until we tear it down and take a closer look. And yes, I am tearing down a collet chuck before using it. I can learn.
This particular unit is a number 5CA-D3. It's marked with the Hardinge-Sjogren brand. I know there are a bunch of different vintages of this particular collet chuck, and this one's been around for a while. All this debris in here looks to me like grinding dust. It is magnetic. It might just be the fine chips from turning, or maybe this was used on a grinder at some point. The action's fairly smooth. I can feel just the tiniest little bit of grit inside it. It doesn't seem too bad, but if you look in the back, yeah, that black grinding grit is just through everything. Now the taper's actually in pretty good shape, so I have high hopes for the concentricity of this chuck, but we're really not going to know until we get it cleaned up and actually on the lathe and spinning. There's lots of grime down here around the hand wheel, and I'm not sure how I'm going to get that out. I'm a little bit concerned about the rubber overmolding. It does seem to be solidly attached, and it does seem to be pretty much intact, even though it's a little bit beat up. We'll have to play around with that and see if we can get that cleaned out. There's quite a bit of junk down in there. Now the taper in the nose looks relatively clean, but there is definitely some wear. You can definitely see these ridges where the gaps in the collet ride. I don't know how big a deal that's going to be. I can feel it with a fingernail. The taper could always be reground, so it may not be that big of a deal, but we won't really know until we get this thing cleaned up and on the lathe. So we might as well tear it down and get started. I would kind of like to know what I'm getting myself into before I get myself into it, so let's go out to vintagemachinery.org and see if we can find some documentation. Click on Manufacturer's Index and type in Hardinge. Here's Hardinge Brothers, and then we'll go to the Publication Reprints tab. There's a lot of stuff in here, so I will just hit Control F to search and search for the word chuck. And there's a bunch of stuff here. These look like general line catalogs. Here's a parts list. That looks promising. Looks like there's a couple of those. I'll just control click on those and open them in other tabs. I look down through the rest of the list here, and there do appear to be some more line cards, but I think that parts list looks the most promising. Looks like the first one's for the lever type. That's not what I have. This is the step chuck type, which is similar to what I have. It looks like this covers threaded spindle nose, taper key drive spindle nose, and cam lock. Cam lock is exactly what I have. That's on page 2. And here's a cutaway drawing. So it looks like the outer hand wheel is connected to a ring gear that drives a set of planet gears that then drive the center ring that is threaded to pull in the 5C collet. Now this looks like it's a compound gear train. So there's a large gear and a small gear on each planet. So the hand wheel ring drives the large gear and the small gear drives the inner ring. So that would develop some mechanical advantage. And it looks like there is a thrust bearing. Now this drawing is only showing a separate thrust bearing race on one side and the other side bearing directly on the body of the chuck. We'll have to see when we get this torn down. That doesn't seem right to me. I would think you'd want those on both sides. And it looks like the chuck is just in 2 halves, probably aligned with the planetary gear pins and held together with the 4 screws on the front. The back here is showing the D1 style taper with the cam lock pins. Again, this is exactly what I have. Now, mine doesn't have this diagonal port or any of the extra geometry on the front for holding a chuck on the front of the chuck, which is sort of interesting, but I don't think any of that's going to matter. All the rest of the mechanical stuff should be the same. So let's go out in the shop, tear it down, and find out. When I took my last 5C collet chuck apart, I determined that Allen wrenches are for chumps and impact is the way to go. I've got this on the lightest setting, and that looks like that's going to be plenty. Oh, isn't that lovely? What is that? Oil, grease, grinding soup. I don't know what that is, but I'm glad I'm taking this apart. Now, even with the screws out, I was unable to get this thing apart, and so I decided to need a little bit of tapping with the drift. And the easiest way to do it is just to set the hand wheel up on a couple of little plastic boxes, drop a piece of stock in one of the screw holes, and tap lightly. And that's all it takes. Separate the back. More soup. I'm not sure the best way to take this apart. We'll try just taking the back off. And it looks like the planetary gear pins came with that. Let me put it back together and take it apart from the other side. And of course it's stuck again. So let me find my drift here. That's better. Yeah, looking at the inside of this, I don't immediately see any issues. You can see how this functions with the compound planetary gear mechanism. I think that's a felt seal I'm looking at there. I'm a little bit concerned about the timing here, so I'm looking for timing marks on the gears. And I'm just not seeing anything. I've seen some other references in other places to there maybe being some light timing marks on these gears, but I scoured these carefully and I just do not see timing marks anywhere. So I guess when this goes back together, we'll just have to figure that out. They are dirty, but everything in here so far looks okay. Gear teeth all look great. I don't see any wear at all, though I wouldn't expect it to show much unless the gears were really soft or something. Sun gear here has another felt seal on the back side that runs in this groove on the I guess the back casting. Those are pretty worn. I might want to do something about that. We'll get this cleaned up before I decide what's needed there. But the parts look okay. I don't see any appreciable wear on anything here. This all looks to be in pretty good shape. You can see the felt seals are just pressed into a groove there. So those should be easy to replace, or they might be fine. We'll have to take a look when we get it all cleaned up. And aside from being dirty, I don't see anything on the back here that causes me any kind of concern at all either. It's going to take a lot of elbow grease to get this cleaned up, but other than that, I think this is all going to be fine. All the running surfaces look smooth. I don't see any scoring. See if we can get this thrust bearing out. And here's the hardened washer from the back side. It was shown in the drawing, and that looks okay. I don't see any scoring. I don't see any pitting. That looks to be in really good shape. And the bearings are the same. They're just really dirty. They're caked up in grease, which is fine. But I don't see anything wrong here. This is going to take some work to get all that grease out of there and replace it with fresh. Now the question is there a bearing race on the front side? And the magnet's not pulling anything out. And I certainly can't see any seam in there. So maybe it really is just running right on the casting. Or I guess it's a machined steel part. It looks good. I don't see any damage. I don't see any pitting. But I also definitely don't see a bearing race down there. Now let's see about this Zerk fitting. I've got some sockets here, but I've tried a bunch of different sockets and I cannot get anything to fit it. So maybe it doesn't have a hex on it. Let me get some of the junk out of here. And boy, I don't see any flats on that at all. Maybe it's a press-in Zerk fitting. I didn't expect that. I've never actually seen one. I didn't know they existed, but that's sure what this looks like. You can look at it from the back side, and I just see the same thing. It looks like a small hole with a tube pressed into it. So apparently it's a press-in Zerk fitting. I don't have a replacement for that, and I don't plan on using it anyway. I plan on just greasing this and leaving it alone. So I'll just clean this out and we'll just leave it be. I don't need to borrow any trouble. And if I do manage to force that thing out, then I'm going to have to deal with it. So let's just clean it up in place. For cleaning, I am just going to start with WD-40. I'm not using this as a lubricant. I'm not using it as a rust preventer. I'm just using it as a solvent. Just looking for something that will break up the grease so that I can wipe it away. I'll just work it in here with an acid brush, try to dissolve as much of this as I can, wipe it out with paper towels, and repeat. And unfortunately, this is going pretty slowly, but I'm concerned about using anything stronger like brake cleaner or something like that because I don't know how the rubber on this hand wheel is going to react. And this is by far the most difficult part to clean. You can see that the WD-40 and brushing is just raising all kinds of soupy gunk out of the grooves in this thing. And unfortunately, there's still a lot in here. It's just barely touching it. I tried a toothbrush and this didn't touch it. I tried it in the sink with dish soap and that really wasn't touching it. There's just so much in there. And ultimately I decided to crack out the ultrasonic cleaner. And this is ultimately what I found that got this stuff out the best. And that is to just put it in the ultrasonic cleaner. This is water and dish soap running at 50 degrees Celsius. And I'm scrubbing with the toothbrush while the ultrasonic cleaner is running. And that made short work of this. And by short work of it, I mean, I probably spent 20 minutes with a toothbrush getting all of the gunk out of there, but it did a nice job and it left a nice clean surface. It got it clean. It does not appear to have damaged the rubber. So given that success, I went ahead and ran everything else through the ultrasonic cleaner, which is probably what I should have done initially just to save myself the time. And it came out relatively clean. This is not final. I'm not totally happy with it, but it certainly took a lot of this off. I think I'm going to run everything through it a second time. And this is what I'm using. And this is just 50 degrees Celsius water with palm olive dish detergent. I'm not using palm olive because it's special. It's just what I found under the sink when I looked. I'll just run this for about 20 minutes, again with the water at 50 degrees Celsius. You can see a lot more gunk came out of that. And these are now finally starting to look pretty clean. Of course, they're wet, so I'll blow them off with compressed air just to try to get as much water out of here as possible. And we'll get some more lubricants or some oils or something on this here pretty soon so that they don't rust. Nothing really flash rusts in the climate where I am, but I still don't want to leave this bare steel exposed for very long. Now, interestingly, after running this all through the ultrasonic cleaner and taking another look down in the bottom of this bearing race, there's a hardened washer down here. I couldn't see it with the grease in there. I couldn't even budge it, but after going through the ultrasonic, there definitely is a separate part here. There's very little under it. I think the grease film was really thin and was just holding it in securely. I think that's going to be clean enough, especially since nothing's going to contact it. I think we're ready to do some assembly. I looked and you can actually buy replacement felts for this collet, but these are actually in pretty good shape. I just want to help them out a little bit. So I grabbed some 100% wool yarn and I'm just going to put a couple of strands of yarn underneath the felt just to give it a little bit of extra compression. On this small one, I think a single wrap of the yarn is enough. Just cut that off. Saturate it with oil. And tuck the felt in over the top. So this will just lift the felt a little bit and replace some of the compression that's been lost from wear. And this really should be enough. This felt's in pretty good shape. The larger felt on the other side needs a little bit more yarn. I'm going to go ahead and put 2 wraps of yarn under here. Clip that off, saturate it with oil, and tuck the felt in over the top. And all this is doing is it's just going to provide a little bit more volume and it's going to push the felt up out of the groove just slightly, and that should be plenty to restore the seal. The seal is probably fine the way it was, but this will just guarantee it. Now, a lot of these places are going to have grease. I'll go ahead and get a little bit of oil on most of these surfaces and wipe it off. I'm mostly just concerned about rust prevention. Again, there's going to be grease almost everywhere, but a good coating of oil on everything before I start will prevent things from rusting. I'm just going to use this red grease. I threw the question out on the internet and asked the internet what I should use. I was debating between using the red grease and using moly. The consensus was that the red grease is the way to go. I think the moly would have been fine too. I think the big difference is the red grease is going to be a little bit sticky, and if I used black moly, I could use less grease and perhaps have a little bit less static friction. But honestly, the stickiness is probably going to be a benefit to keep the chuck from coming loose when the lathe is spinning up and down. I really don't know. There's not going to be a lot of acceleration, but suffice to say I'm using red grease, and I'm just putting everything together here with a coating on everything that moves. I put a little bit more grease in the bearings than I'm putting elsewhere. Every place else I'm just getting a light film. It's just there for light lubrication. I don't want it coming out of the chuck, and there's no reason to overdo it. No real reason to cake this up. As long as there's a film on all the surfaces, we should be just fine. And when this goes back together, it's important to get the gear teeth timed correctly. The Planet gears are compound. There are 15 teeth on the small side and 20 teeth on the large side, which means that the teeth only line up at 5 positions around the outside of the gear. In between, the teeth do not align. So I've marked those 5 positions where they align, and I've brought those markings around to the backside so that I can see them. And I need to line up both gears so that they're timed the same with respect to those aligned teeth on the inside and on the outside. So I'll just drop this in here with one of those 5 marks pointing directly at the center axis of the chuck. And that means that there's a tooth on the small side aligned with that mark also through the center axis of the chuck. And I'll just line those up and make sure those are both pointed at the center. If I end up off by one tooth on the small gear where it's engaged in the sun, then on the outside, the ring gear will be off by 1 1/3 teeth. And that will be a problem because then the ring gear won't be centered. So I'm just checking with a scale to make sure I have those lined up through the pins and through the center. Then I'll get the other side greased up and get this ready to assemble. Now, once those teeth are meshed with the sun gear, they will stay timed and I can rotate it. So now I'll rotate it so that I have the marks facing outward, and I've put some corresponding marks on the ring gear. I just counted around, so I have those marks on exact opposite sides. I just counted the teeth, and I'll just line those up with the marked teeth on the Planet gears, and that's all we need to do. We should be perfectly centered. Now, I expected there to be timing marks on these gears so that they could be assembled this way, but there don't appear to be any, so I just counted the teeth and we'll make it work. Now, with everything aligned, with everything greased, with everything timed, we can just put the other half of the chuck on. This is a very close fit, which it needs to be for the chuck to run concentric. And I'll just very carefully work it down. I don't want to draw it down with the screws. I want to get it seated firmly and make sure everything is still free before I start tightening the screws so that I don't end up, jamming something or doing some damage to the chuck. And with that seated and with everything still moving freely, I'll put a little bit of oil on the screws just to keep them from seizing, just to keep them from rusting. And we'll bring everything down tight and make sure that it's all still free. And then we'll just go around and snug these all down. They don't need to be super tight. I'll probably come back later and tighten them up once I'm sure everything's seated and once I'm sure everything is still moving freely. And that actually feels pretty good. You can definitely feel the stickiness of the gear film in there, but the more I manipulate it, the smoother and the easier running it gets. And it is virtually silent. I can't even hear the gear teeth like I could before. That's pretty good. I will make sure that I've got a good oil film on everything. I don't want this to rust over time. And that metal is bare since I used detergent in the ultrasonic cleaner. I've got some little cotton swabs here so I can get down in all the crevices, and I just want to make sure I've got a good coating of oil on everything, and then I'll wipe it off. And in this climate, that should be plenty. This will never rust here. 5C collet runs in nice and smooth. Comes out nice and smooth. I'm pretty happy with that. so much better. And from this angle, you can see that Zerk fitting, that there are no flats on it. It is just a press-in Zerk fitting, I guess. Just make sure I've got all these surfaces coated with oil. And that collet chuck is done and ready to run on the lathe. Now that I see it sitting here all pretty on the workbench, I'm noticing that these fasteners are kind of dinged up. It almost looks like somebody used an impact wrench on them. I probably should replace those. It doesn't matter, the factory fasteners are going to be nice and strong, but I might replace them anyway. All that's left is to set this slightly off center in the frame, take a nice thumbnail, and this project's done.
Of course, I don't actually have a lathe with a D13 spindle nose, so I'm going to have to do something about that, but not today. If you enjoyed this video or found it useful, give it a thumbs up, subscribe, and maybe consider supporting the channel over on Patreon. And if you're already a patron, thank you. You make it possible for me to do this. Thank you for watching.